Okay, so I wanted to go over some types of data with you beyond what I asked you to read in the textbook, just to break it down a little bit and talk to you briefly about Likert scales because most of us, when we give surveys in education, we're dealing with Likert scales. So we can talk about those in terms of quantitative versus qualitative. All right, so we have two broad types of data, quantitative data and qualitative data. Think quantity, so numerical. Think quality, so kind of an adjective or a description. And these two fields kind of determine what type of researcher you are. So with quantitative, where it's consisting of numerical values that typically either represent a count or a measurement. All right, so what year are you in school? What's the temperature, GRE score, any kind of exam score. So this is, again, numerical data, height, weight. It's measurable or it's countable. And then with qualitative data, it consists of values that can be placed into non-numeric categories, all right? So when it is words, this is really easy, right? So if we think about political affiliation or sex or race, ethnicity, this is pretty easy because there's words. You can't do math on words, all right? But then a lot of times qualitative data looks numerical. One example would be social security numbers, credit card numbers, zip codes, all right? These are all numerical, but it's qualitative data because these are labels, all right? That social security number is a label for you, all right? The zip code is a label for a geographical area. And then also, a lot of times, demographic variables, so like race, ethnicity, or gender, get coded numerically, right? So maybe we'll have 0 coded as male, 1 coded as female. That doesn't make it quantitative, it's still qualitative. That 0 represents the word male. All right, and you're going to hear me say this a bunch this week especially, is that it's so important to know your data type because the data type completely determines the type of analyses that you're going to run. All right, so let's talk a little bit about quantitative data. So I already mentioned that we're talking about data that is countable or measurable. All right, and when it comes to measurable, we're going to measure it with a tool. So a lot of times when students are trying to figure out, all right, well, how do I know if it's quantitative or how do I know if it's measurable? How are you getting to that number, right? So if you want to know how tall somebody is, you've got to get a yardstick out or meter stick and actually use that tool to get a measurement. If you want to know how much someone weighs, you've got to pull out a scale and use that scale to get that measurement. All right. One thing about quantitative data is that we can put this data on a number line and we can compare the values. All right, so, and then we can use these values in computations, meaning we can take the average, we can find the maximum, we can find the minimum. All right, again here, weight, number of students, number of cars in the commuter parking lot. All right, and the key with quantitative data is that we can show it as part of a distribution, we can summarize the data. This is in the realm of descriptive statistics. And so we can calculate averages, we can do a histogram, we can mark maximum and minimum values, we can calculate something called the standard deviation that I'll be going much more into next week. All right, qualitative data, as I already mentioned, is non-numerical. All right, and I mentioned that it can be coded as a number, so you want to be careful. You want, whenever you're dealing with numbers, you want to say, okay, what does this number represent? If that number represents a word like male, then it's qualitative. If that number represents, say, a weight or a measurement, it's quantitative. All right, a lot of times the qualitative data is considered a label. All right, so a good example here is education level. All right, so from high school degree all the way up through PhD, we have different education levels. All right, cannot do computations on qualitative data. All right, and as a silly example here, I'm telling you, you cannot average zip codes, you can't add zip codes, you can't subtract social security numbers and get to something new. All right, and so that's the key. That's the biggest difference between qualitative and quantitative data, is that we cannot do computations on qualitative data. All right, when it comes to describing them, again, much more next week on this, but we'll do bar charts or pie charts to try to summarize our qualitative data. All right, there are two levels of measurement, all right, within qualitative data. One is nominal and the other is ordinal. Nominal is whenever it's the name of something, all right? So the key here is that there's no ranking or ordering to the data. So if you take, for example, political affiliation, there's no order to Democrat, Republican, Independent, right? There just are three labels. Same with eye color. There's no ranking or ordering to them. Conversely, ordinal data is ordered, all right? It provides an order, but the problem with ordinal data, why is it qualitative and not quantitative? All right, so for example, let's look here at the example heat, low, medium, high. You may say, well, Angie, I can order that as 1 is low, 2 is medium, 3 is high, right? So we could get maybe some kind of discrete measurement to the heat. But the problem is that we don't know that it's equal spacing between low and medium and high. All right? This is one of the arguments with Likert scales, that when something is ordered, and I give you the example here of strongly disagree to strongly agree, how do you know that there's equal spacing between strongly agree, disagree, and disagree, as well as agree and strongly agree? We don't know precisely that there's equal distance between those orderings, okay? But keep in mind that ordinal data is often coded numerically. All right, two levels of measurement with quantitative data are continuous and discrete. All right, so continuous data is measurable. It can take on any value in an interval. It could have any number of decimals. And again, this is measurable data. We're having to use something, some tool to get to that measurement, whereas discrete data is countable. All right, it can only take on particular values. And again, these values are either counted and or listed. Keep in mind the list may be infinite, but still the values can be listed. Examples would be number of students, number of companies in the Fortune 500, shoe sizes, etc. All right, so this is just breaking it down for you, just showing you that the levels of measurement with qualitative, as I mentioned, are nominal and ordinal. And then the first breakdown for quantitative is discrete and continuous. But discrete and continuous data can be either interval data or ratio data. So we want to talk about the difference between interval versus ratio. All right, so intervals of equal length signify equal differences in the characteristic. All right, what the heck does this mean? What this is saying is that the difference in 120 pounds and 130 pounds, meaning 10 pounds, is the same as the difference between 180 pounds and 190 pounds. All right, so that 10 pounds means the same at different places on the scale. This is something that makes Likert scales arguable as to whether it is, and let me go back. Likert scales could either be qualitative ordinal or they could be quantitative discrete interval. All right, and it's based on an assumption that you're going to make. All right, Differences in interval data make sense, but ratios do not. And what do I mean by ratios? We can't get into the twice as much as or the half as much as. So 100 degrees Fahrenheit is not necessarily twice as hot as 50 degrees Fahrenheit. All right. It occurs, and when does this happen? It occurs when a numerical scale does not have a true 0 as a start point. All right. And so there may be an arbitrary 0 like we have with Fahrenheit. There is a 0 degrees Fahrenheit, but it's not necessarily the absence of temperature or the absence of heat. All right. And again, it may initially look like a qualitative ordinal variable, and this is where our Likert scale comes in. So a lot of times people confuse qualitative ordinal with discrete interval. And it's really just the assumptions that you're making on the equal length signifying equal differences in the characteristic. All right, so for me as a researcher, I tend to put Likert scales at this discrete interval level. Okay. Other examples include IQ scores. Why IQ? Because we don't have a 0 IQ. In fact, IQ scores only go down to 50. We don't know what a 0 IQ is. All right, calendar years, we don't have a 0. All right, now ratio level has more meaning than interval level. Why? Because now not only can we do differences, but we also have meaningful ratios. All right, and so this is when we're getting into the measurable data. So here 4 ounces of water is twice as much as 2 ounces of water. Now we do have a true 0 because we certainly know what 0 ounces of water is. It is the absence of water. All right, and so again, we can do not only the addition and subtraction with our data, but we can do the division and multiplication also. And again, this is when you think of measurable data, those very typical measures: mass, length, time, weight, etc. All right, so in summary here, we've got at our highest level ratio data, which means there's an absolute 0. Okay, then we have interval data where distance is meaningful, but we do not have that absolute 0. And then we have ordinal, which means the attributes can be ordered. And then at our lowest level, we have nominal, which is the attributes are only named. And again, I will say it one more time, that the type of data dictates the type of analysis that you're going to run.